Hey guys, welcome back to another video. In this video, we're going to be kind of continuing what we talked about in the last video. So we're going to be analyzing graphs of polynomial functions. So let's say we've got this polynomial function here. I went ahead and identified the turning points. So turning points are either going to be maximums or minimums. For example, we have a maximum point right here and a maximum point right here. And then we also have minimum points. We have a minimum here and a minimum over here. So now we want to look at where the graph is increasing or decreasing. So we can see if way over here on the left side, we're increasing to begin with until that turning point where we start to decrease. And then at this turning point, we start to increase and then start to decrease and start to increase. So we've got 1, 2, 3, 4, 5 different segments in this graph where we could have different behavior. So if we're trying to identify where our graph is increasing, we'll start with this first section here. So for the places where it's increasing, we can say everything to the left of -2. So -2 is our x value. So everything to the left of -2, we're increasing. We're increasing. You can think of it like you're on a roller coaster here, and the roller coaster is like going up, up this track right here. So we can say that it's increasing where x is less than -2. In other words, all these points to the left of -2, we're increasing. We're going upward. Then we're decreasing here. So let's identify that maybe over on this side. Decreasing down here. So in between -2 and -1, we're decreasing. So we could write it like this. We put an x in the middle, little less than signs. So in between -2 and -1, we're decreasing. All right, we're going downhill right here. And then we turn again and start going uphill. So on this uphill part, we're increasing. So we could write underneath the increasings, x is in between -1 and 1. So in between -1 and 1, we're increasing. And then we start going downhill again. So we could say x in between 1 and 3. We're decreasing. And then finally, we're increasing here at the end. So we can say that for x greater than 3, we're going to be increasing. All right, so that's kind of how we identify where we're increasing and where we're decreasing. Now, one other thing I want to show you all today is even and odd functions. So let's go over to here. Guess we're already on this app. And look at even and odd functions. So with even and odd functions, the graph has to look specific ways. So for even functions, the graph has to be symmetric about the y-axis. So that means like if we were to fold this graph along the y-axis, then it would be exactly the same on the left as it is on the right. So they would overlap if we were to fold them like a piece of paper along that y-axis. So that's an even function. An odd function is also the same on both sides, but one side gets flipped. So notice this is exactly the same as this over here, but it's flipped upside down. So that's kind of that would be symmetric across the origin. So it's exactly the same, but it's flipped. And then we also have this other rule that for odd functions, they have to go through the origin. They have to go through the origin. If it doesn't go through the origin, then you get kind of a weird break when you flip. So it's not symmetric about the origin. For it to be symmetric about the origin, with our functions we're going to be looking at, they need to go through the origin. And that's just for odd functions. Notice for the even, it doesn't have to go through the origin. So if we looked at these functions down here, plug these into Desmos, see what you get. I'll go ahead and give you the answers. That way you can see kind of more examples of what they look like. This first one is an odd function. It's an odd function. The second one is an even. Both of these are pretty easy to see when you graph them on Desmos or any kind of graphing calculator. Pretty easy to see that this one's odd, this one's even. And this last one's kind of tricky, but it's actually going to be neither. And let me show you why. So I'll try to sketch a little graph of it. The graph kind of looks like this. Kind of goes up like this, evens out, and then goes up again. And it almost looks like it's an odd function, except it doesn't go through the origin. Notice it doesn't go through the origin. So since it doesn't go through the origin, it's not an odd function, so we say that it's neither. Okay, guys, I guess we're going to end the video there, but if you have any questions, let me know, and I'll see you next time.